Rain1290 with you to bring you another risk analysis for thunderstorms. In this case, a strong to severe thunderstorm risk for July 10th, 2025 from pre-dawn to especially late afternoon to evening. If there are any changes to this outlook, I will mention them in the comments below, so look out for those updates. But in the meantime, let's look at an investigation as to why this risk exists altogether. So up to the northeast, we're seeing these frontal boundaries here taking place. So in this particular case, this is a cold front that's trying to move off to the east, a fairly weak cold front, and it's becoming occluded as represented by this purple section. So this will be the primary driving force, in addition to some shortwave troughs that I'm going to show momentarily. Okay, so let's start with average cloud cover expressed as a percentage. So what we're really interested in are these darker patches, which represent clear breaks. So let's go into July 10th, since that's the day in question. And this is now pre-dawn, 2 o'clock in the morning, July 10th, and you're already seeing these breaks taking place, although they're not as important during pre-dawn. But let's go towards the later morning, which is now 11 o'clock in the morning, and you're seeing these large clear breaks taking place. And this stays with us right throughout the afternoon to late afternoon. This is now up to 8 p.m. on July 10th, and you're seeing these large breaks still sticking around. So we know we have a healthy dose of sunshine getting through this cloud deck and helping us to destabilize the lower atmosphere. Now, as a reflection of those clear breaks that I showed previously, we want to see how well the low-level lapse rates follow suit with that. So right now we are in pre-dawn July 10th. Obviously, we don't expect brighter colors during pre-dawn, but we do expect them to brighten as we go further. So let's see if that matches our breaks in the cloud deck. So now we're going to the late morning, and you're already starting to see these brighter colors overspreading East Ontario to Southern Quebec and much of the Northeast, and then going into the early afternoon to mid-afternoon and into the early evening. So you're seeing these really steep cooling rates that are taking place thanks to the sunshine that we're receiving. So we're seeing rates of up to as much as 9 degrees Celsius per kilometer. So that's how these are expressed in degrees Celsius per kilometer. So we're seeing these brighter colors taking place, and that makes sense because we are seeing those clear breaks. Now, another area of focus are the mid-level lapse rates. So we want to see if this is going to join forces with those lower destabilization rates that we saw. So what we're looking for are these grayish looking colors and even into the greens or better. So that represents the steepest rates. So right now we are in the morning of July 10th. And we're already seeing some pretty good mid-level lapse rates here, about 6 to 7 degrees Celsius per kilometer. So let's go into the afternoon and see if this continues and if it follows suit. So right now we're into the mid-afternoon. They're somewhat modest, but we're seeing this area that's starting to move to the east and this steeper zone of cooling. So going into late afternoon, so this is 8 p.m. and you're starting to see these brighter colors starting to appear. So going to the evening, late evening even, we're seeing these areas of steeper rates. Okay, so let's look at surface dew points. So this is a reflection of how much humidity is in the air, how much moistening is taking place. So the higher the dew point temperature, the higher the amount of moistening. Here, the dew point temperature is represented in degrees Fahrenheit. So this is late morning, actually. So 11 o'clock, and you're seeing this zone of moistening taking place. So we're getting dew points. It's not particularly high moistening, but it's still enough to send dew points into the low 70s in some cases. So that represents very high humidity by late morning in a lot of these areas in Eastern Ontario to Southern Quebec. High 60s, low 70s dew points Fahrenheit. So we're seeing that stay with us in large part for the afternoon period and going all the way up to the late afternoon. So you're still seeing those dew points sticking around, including around the island of Montreal. So this is helping to fuel the amount of instability that's taking place, in addition to the amount of sunshine that is occurring, as well as the mid-level lapse rates that I showed previously, the steeper rates that were shown, including for this time frame. And then going into the late evening, you're still seeing that stay with us in these regions. So this will be an area to really keep an eye on. Okay, so looking at CAPE, so this is a metric of instability. It represents how much instability is in the air. So the greater the amount of CAPE, the greater the amount of instability. Really what we're seeing here are these somewhat lower values at this point. So we're getting values of about 500 to 1,000 joules per kilogram, but that makes sense because this is pre-dawn July 10th. I would also envision a chance for thunderstorms during pre-dawn of July 10th, so this will be something to watch ahead of that warm front. Now, let's go further into the day as usual. And now we're getting to the later morning and you're starting to see these larger areas of instability taking place, even up to 2,500 joules. by late morning. That's pretty high for this time of the day. And then going into the afternoon, we're still seeing that stick with us. And right into the evening, this is late afternoon of July 10th, and we're seeing zones of 2,500 joules per kilogram still taking place, and right to the late evening. So this is pretty high after sunset, I would think. So again, if the lift is strong enough to take advantage of this, I would expect particularly rigorous thunderstorms taking place in Eastern Ontario to Southern Quebec and upstate New York at the time. Okay, so as an evaluation of our surface boundaries, in this case a warm front that's well off to the southwest, we want to see how much lift is actually taking place to the northeast of it as we go further in time. So right now we're at the evening or late afternoon of July 9th, so we want to see if there are any larger amounts of convergence taking place. So this map is really a reflection of surface moisture convergence. It's measured in grams per kilogram per second. So what we're really looking for in essence are these brighter colors to appear in these regions. So we are actually seeing this maximized area during pre-dawn, 2 o'clock in the morning. So again, I had stressed before that we could see an area of increased convergence that could take advantage of that morning instability that's taking place, and that could actually allow for some pre-dawn thunderstorms to appear in southern Quebec, eastern Ontario as well. So this will be an area to watch during pre-dawn. But let's go further into late morning. So we're not seeing all that much lift beyond pre-dawn. So this is late morning, now going to early mid-afternoon still. So not that much taking place here, but let's go late afternoon. Still not a great deal, although we are seeing some increases in lift taking place eastern Ontario and parts of southern Ontario and going east of the Montreal area. But let's go into late evening, and you're starting to see this area that's starting to form around the island of Montreal as well. So this could also take advantage of that instability that's present at that time. So as another source of lift, we want to evaluate mid-level forcing for ascent. And one way to do that is to look for shortwave troughs. So this is the 500 millibar altitude, approximately 5.5 kilometers above the surface, or approximately 3 miles above. And it's measured as a vertical velocity in microbars per second, so how quickly the air is rising at these altitudes. Let's go into July 10th. So much like surface convergence, we're not seeing all that much taking place in Eastern Ontario, Southern Quebec. Some local patches of maximized lift in upstate New York and a portion of East Ontario. But let's check into the evening, and you're actually seeing this area here, this localized maxima taking place around late afternoon to early evening of July 10th. And this could be an area where thunderstorms could actually erupt and take advantage of that instability I mentioned before. So we'll have to see if this actually sticks with us in upcoming runs and determine whether the thunderstorms will likely take advantage of that if it continues. So this is late afternoon, and now going into the late evening, we're not seeing all that much late evening. So although we did see some maximized surface convergence taking place in this area, so even though we don't see that lift from the 500 millibar altitude, this could also imply that surface convergence could take over at that time to promote thunderstorms later into the evening. Okay, so just to quickly examine the Skewlock P diagram, this is from the west end of Montreal during the late afternoon, so around sunset. So the reason for this is that lift tends to increase as we go later into the afternoon, into the evening. So I just wanted to focus on the profiles for that time frame. So really what we're seeing is the cape that we looked at previously, almost 2,000 joules per kilogram by late afternoon, and is distributed over a pretty large tropospheric depth. But two things I also want to draw your attention to: extent of cooling that's taking place at 500 millibars. So we're actually seeing a temperature of approximately minus 12 at 500 millibars. So pretty cold temperatures at and around 500 millibars. And at the same time, we're seeing this steep drop in moisture taking place at the mid-altitude. So what we call is a hydrolapse. So this represents a steep decline in atmospheric moistening at these altitudes. Why this is important is it can actually encourage locally strong downbursts of wind because of dry air entrainment becoming more important. So this can actually fuel that hazard. Now, if you look at our shearing profiles, it's pretty much unidirectional, not a particularly intense shearing profile. This is it's on the weaker end, I would say, in terms of how this is oriented. So we have fairly unidirectional shearing fields, not that much of a wind factor at 500 millibars in terms of speed. So I don't expect intense organization for thunderstorms altogether, but this is still marginally enough, I think, to support some organized thunderstorm families. And as I mentioned, with this cooling that's taking place aloft and to some degree this drying effect that's also taking place, I think this will maximize the chance for rigorous lightning with some of these thunderstorms, at least temporarily, as well as small to even medium-sized hail production. And again, that locally strong downbursting effect along the gust front. So strong winds locally are possible with some of these thunderstorm families. So this is something we'll have to watch into the evening, late afternoon to evening period. I'm really focused on this area here, like around the Montreal area, just to the east and also to the southwest into eastern Ontario and portions of upstate New York as well, and other pockets of initiation, I think, will be favorable in south central New York and parts of Pennsylvania as well. So these thunderstorms are not particularly fast moving, as I showed with those shearing profiles, but they will be capable, again, of small to medium-sized hail, intense lightning in some cases, since we have a profile that really supports intense lightning in these zones. So thunderstorm motion will also be something like this. So again, not too fast in terms of motion, but this is pretty much what I would expect them to do in terms of speed or displacement. Again, I also think that thunderstorms will be capable of locally strong downbursts along their gust fronts, so there is that window of opportunity for those. Tornadoes seem very limited in terms of a risk, so I don't really consider a tornado risk as much as I do a locally damaging wind risk, but there is also a chance for local flooding as well, since precipitation rates will be quite high. Sub-hourly rainfall rates will be particularly high in these zones, I would think. So that will be the hazards. Those would be the hazards, I think, with these thunderstorms. So I mentioned previously that pre-dawn will also feature an opportunity for thunderstorms to take place north of that warm front. So I think this zone will also be favorable for that during pre-dawn. Now, they're fairly isolated in coverage, the thunderstorms themselves, but they'll also be following a similar trajectory as that afternoon situation that I showed previously, late afternoon, evening. Rainfall risk will be more of a factor for these thunderstorms that take place. So again, not too many of them, just like the late afternoon to evening. There aren't that many thunderstorms taking place since the lift is pretty modest throughout the day, but later in the afternoon to evening, that lift does improve, and I think we can see an upgrade to scattered at that time. But until then, we see mostly isolated thunderstorms among the scattered rainfall coverage that's taking place, the convective rainfall that's taking place. So if you made it this far, thank you very much for your attention and your viewership. We always appreciate it. Well, this will be the situation for, again, July 10th, 2025 for the Northeast, and especially Eastern Ontario to Southern Quebec, I think, where lift will be maximized. If this starts to change with the newest data that comes in later today and early tomorrow, look to the comments below and you will see updates to revise what's been presented in this video. And if you, again, found this interesting or if you found it insightful, feel free to subscribe to not miss out on upcoming videos, forecast videos, and thunderstorm documentation altogether. So once again, thank you very much. I'll see you in the next video.